Hello students, today we are going to do the alcohol, phenols and ether. Today we are going to focus on ethers. Let us see how we are going to deal the entire chapter on ether in step-by-step process. First to go is about the structure, followed by the nomenclature, then about the preparations of ether. With the preparation, we will go with the physical properties, chemical properties and uses. So if you can make a chart on these very points, chapter ether will be completed. So now let us focus on ether. The word ether has come from the word either, A-I-T-H-E-R, either, which means clear sky. And in Greek language, it is also called as air. So, ether is something which is airy, that is, it is volatile. And we can say they have the alkyl or the aryl derivatives of water. So, if you see the structure of water, right from class 11, you have been doing the structure for water. So, here we know that oxygen has two lone pairs and a bond pair with hydrogen, making an angle of 104.5 degree. So it is a bent structure. So you can see this is the structure for water. What's the angle? 104.5 degree. Now if we go for ether, you can see this is the same, the lone pair of electrons and a bond pair with an alkyl or an aryl group. So what is the difference between water and the ether? The structure is almost same. Only the angle may vary. It comes around 112 degree here. So student, what is the structure? What is the general structure for ether is, we write down ether as R-O-R dash, where R may be equals to R dash or R may not be equals to R dash. So here you can see the number of the carbon atom may be same on both the sides or may not be same. If the number of carbon is same on the both side of the oxy group, what we call as the ether group, then it is called symmetrical ether. Otherwise, it will be called as unsymmetrical ether. If we focus now to the structures of water once more, you will see that this is the lone pair, this is the lone pair, and this is the bond pair, making an angle of 104.5 degree. Now if I go for seeing the structure for alcohol, there I would see the same thing. There is the lone pair, there is the lone pair, bond pair with CH3, a bond pair with a hydrogen, making an angle of 108.9 degree. So this is all about alcohol, CH3OH. Now if I substitute, so this hydrogen has been substituted with an alkyl group. Now if I substitute this very hydrogen with another more alkyl group, so this is alcohol, this is water, and if I draw one more structure, this about the ether. If I draw here CH3, it becomes ether, and as I have told you before, the angle between them becomes 112 degree. So students, you can understand, the more you have the alkyl group, more and more the carbon group, this carbon and the hydrogen, they are repelling because of their plus I effect. More is the plus I effect, or they repel each other and makes the angle wider with the number of carbons. If I see here one more with having a lot and lot of carbon, say here I have C and then CH3. CH3 whole thrice. CH3 whole thrice. Similarly, here C with CH3 whole thrice. Can you just tell me what the angle should be, students? So this is 104.5, this is 108.9, this is 112. So this should be something more than that. So here we have 132 degree. So the repelling between the carbon-carbon compound or the radicals is more. So greater the number of carbon, more is the bond angle, and you will have different structure. Though is the bend structure, the angle varies. So keeping this in note, you have to take ether in consideration that it is alkyl or aryl derivatives of water. So if questions being asked what is ether, you have to say it is either alkyl or aryl derivatives of water. Why water? Because you are replacing the hydrogen with an alkyl or aryl group. Like if I talk about the aryl group, it would be say C6H3, or it would be here CH3. So it will be an aryl and an alkyl. Or both the side, it can have C6H5, here also C6H5. So this can be said as an aryl group. So diaryl ether. So in this case, we have differentiated it. So our next work is to go on the nomenclature. Obviously, the nomenclature we will be doing here is on the IUPAC. I have written some cluster of 8 such kind of compounds, and let us see how we can name them easily. So here you know that if it is like CH3OCH3, so the number of carbon being same and it is both the alkyl group, we call this as methoxymethane. So what would be the name? Methoxy, because of this oxygen we call this oxy, and one methyl group here, so methoxyethane, ETHANE. So you have to take this oxygen together with that very carbon which contains the less number of hydrogen. For example, if I change it here as CH3O C2H5, we can call, because this oxygen will be added together with that very carbon which contains a lesser number of hydrogen. So we will take into consideration again methoxyethane, and not the vice versa. We cannot call this as ethoxymethane. No, we have to name the oxygen together with the carbon with less number of carbon contents. Like if I have here C2H5O and C4H say 9. So in this case we can also presume that this would go together with the ethoxy. So you can write here ethoxy, and the C4 is butane, butane, butane. So in this way we have to name it as, so here O means here oxy, the word comes here oxy. We cannot just simply write ether because it is a common name. We are learning the IUPAC system of nomenclature. So student, let us see now. We will be having some few examples, and these examples are very, very interesting because they are not alike. They are something different, and if you can go with this 8 example, I think you will be thorough with the nomenclature part. So student, if I have the cluster of some 8 such important these structures, so we can go with naming this compound. Let us see, as I have already told you, this is called as methoxy, methoxy. Methoxy, this is methoxy and this is ethane. Methoxyethane, ETHANE, ethane. Methoxyethane. So what would be the name of this compound, student? This would be again methoxy, 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 and this is benzene. So we can write here benzene, methoxybenzene. So it has got alkyl as well as the aryl being bonded with the oxy group. Now when we go to this very part, you can see this is the second carbon being attached with a methyl group and carrying an oxy. So here we have to write this is 1, then this 2, then this 3 and this 4. This is the methyl group, and this methyl group is attached. This methyl group is attached with the oxy group because it is a small. This methyl group contains a less number of carbon with respect to that of the butane. So we will write here 2-methoxy, methoxy. Methoxy, दो नंबर में है methoxy, 2-methoxy, and this will be butane. So butane. So 2-methoxybutane. So on the second carbon of the butane, you have the methoxy being attached to the second carbon of the butane. If I go with this part again, you can see there is an oxy group here. So this is methoxy. Here also one methoxy. So how many methoxy, student? There are 2 methoxy. So we can go on writing as this is carbon number 1, this is carbon number 2, number 3 and number 4. This is the first carbon. The first carbon contains a methoxy. The first carbon contains a methoxy. So I can write it as 1,1 dimethoxy, methoxy. So first carbon, in the first carbon you have a methoxy, and again on the first carbon you have a methoxy, 1,1 dimethoxy, and you can see there are 4 carbon atoms. So we call this as butane, butane, butane. So student, when we go for the fifth such kind of the statement here, so this formula we have to make out the name, the IUPAC name. So here you can see if this is the longest chain, if you can take this as the longest chain and this the longest chain, and now you tell me here there are 2 carbon and here there are 4 carbon. So oxygen would love to go together with the carbon containing the less number of carbon atoms. So here you can see oxygen loves to go to that very compound which contains a less number of carbon atoms. So this is ethoxy. Why? There are 2 carbon, so ethoxy. And here this is butane. But to which point it is lying? This ethoxy is lying on the first, second, third and fourth. So you can see this is the second point, this is the second carbon on which the ethoxy is being added. So this is the second carbon containing the ethoxy group. So we call this as 2-ethoxy, ethoxy, 2-ethoxy, and then दो नंबर में ethoxy, and this is butane, butane, 2-ethoxybutane. So if I rub it off, so I will just rub it off to clear the screen. So we'll have a lot of space in naming the rest few. So in point number 6, this is point number 6, you have CH3O, CH3, and here CH3 and CH3. So this is the oxy group, and this group will not go together with this compound. It will go to such compound which contains a lesser number of carbon. So I will just mark it like this. So it is methoxy. And this methoxy, and if I take the largest carbon here, so here this is the largest carbon containing a chain, and I can name it as number 1, number 2 and number 3. So on the second carbon of the longest chain, you get a methoxy, and on the second carbon you get a methyl group. So you can write like this, 2-methoxy, methoxy, दो नंबर में methoxy, फिर दो नंबर में methyl. So again you can write it as 2-methyl, methyl, methyl, and you have 3 carbon compound, so it is propane, propane. So this type of formulas usually the students makes wrong. They get confused, but I always tell you to attach that very oxygen to that carbon with that compound which would contain the lesser number of carbon atoms. So here this is methoxy attached to the second carbon, the methyl group attached to the second carbon, and so the rest is about the propane. So 2-methoxy, 2-methyl, and a propane. So I will go to the 7th point or the 7th formula, and I would go thoroughly stating about a cyclopropane. This is a cyclopropane, and this cyclopropane would have an oxygen attached to it. This is CH, CH2 and CH3. Here there is a CH3. Okay, a branch chain, the CH3. So what would be the name of this compound? So student, you can see this is the longest chain. So being a longest chain, you take into consideration. This is the longest chain. And this longest chain, I will name it as 1, this is 2, this is 3, and this is 4. I cannot name it as 1, 2, 3, 4. Why? Because this oxy group which is attached to the cyclopropane is attached to the second carbon. But if I start from here, it will be the third carbon. So I will write here 2-cyclo, CYCLO, cyclo, and this is propoxy, cyclopropane. So propoxy, POXY, because the oxygen is attached to the cyclopropane. So 2-cyclopropoxy, and this is butane, butane, butane. So I will tell you once more, this is the second carbon. On the second carbon, the oxy group is attached to the cyclopropane. So 2-cyclopropoxy and a butane. This is all. And last to go is such a compound. Let us see. I will be drawing the picture once more. This is point number 7. And the 8th one is CH2, CH2Cl or CH3. Okay, so I can be writing as Cl. So in this way, if I have the number attached to the first and second carbon with the oxy group, remember that you cannot take this as 1. Why? Because we have to give importance to the halo groups. So here we have to give dominancy to the halo groups 1, 2, 3 and 4. So here you can say it has 1 chloro. You can see this written as 1 chloro, and so I will write here 1 chloro, 1 CHLORO, 1 chloro. And this is third and the fourth. So this is third and the fourth. So 3, 4, 3, 4, epoxy, 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 and there are 4 carbon atoms. So we can say it as butane, BUTANE. So this is the 4th carbon atom. So 3, 4 epoxy butane. So this is all about. And very soon I am going to show you about the crown ethers. So these are all simple ethers. Now I will be showing you some areas where we are using the crown ethers. What is crown ether and what the uses of crown ether. Now I will be discussing on the crown ethers. This is something different. So we have already learned about simple ethers. Now crown ethers. Ethers, due to the polar nature of the CO bonds and the presence of 2 unshared electron pairs, we have just seen earlier on this part that it contains 2 lone pairs. So the presence of the 2 unshared electron pairs can form complexes with metal ions, that is a coordinate complex. And the strength of the metal oxygen bond in this complex depends upon the structure of ether. This is how the crown ethers come. Crown ethers, which are polycyclic polyethers containing 4 or more than that of ether linkages in a ring of 12 or more atoms, and it forms stable complexes with metal ion than the simpler ethers. I repeat, student, please see the red lines being drawn up saying crown ethers, which are polycyclic polyethers. It contains 4 or more than 4 ether linkages in a ring of 12 or more atoms, and it forms stable complexes with metal ions than that of the simple ethers. In our next page, we will be seeing about the crown ethers. They are the cyclic polymers of simple molecules of ethylene glycol, and its repeating unit is OCH2CH2. So here you can see this is that O and this is CH2CH2. Similarly, here you have O and then here CH2CH2. So you can have 4, you can have 5, you can have 6. So in this way we try to name the ether, the crown ether in this way: crown 4, crown 5 and crown 6. Now the question is, what about 12, 15 and 18? Here 12 indicates number of oxygen and carbon atom is 12. So if I have here 1, 2, then 3 and 4, 5 and 6, 7 and 8, there are 8 carbon and 4 oxygen, 1, 2, 3 and 4. So 8 plus 4 is 12. So 12 atoms are there, and this is crown of 4. So 12 crown of 4. Here there would be as many as 5 oxygen atom and 8 carbon atoms. So 8 carbon atoms with 5 oxygen atoms makes 5 and 10 carbon atoms makes here 15 particles or 15 atoms, and there are 5 oxygen atoms, so it is called as 15 crown of 5. Similarly, here you can have 6 oxygen atom and 12 carbon atoms surrounding it. So 12 plus 6 is 18, and 18 crown of 6 because 6 oxygen atoms are present. This is how we name the crown ethers as 12 crown 4, 15 crown 5 and 18 crown 6. Now, two names that we are to include here are, one is cryptands and the other is cyprides. So cryptands in cyprides. This is all I can tell you, students. Whatever you have seen just now, that is about the crown ethers, they are called as the cryptands. These are called as the cryptands, and cyprides is when they attach to the metal like sodium ion, potassium ion. So crown ethers are called as host. So these crown ethers are called as the host, and sodium and potassium are the guest. So here we are using lithium, sodium, potassium. So here you can see crown ethers are the host, sodium ion, potassium ion, lithium ion is the guest, and the product formed is called as the inclusion compound. And the product which is formed between them, between the metal and the ether, is called as the inclusion compound, and such kind of compounds are also called as cyprides. Like potassium permanganate, which is insoluble in benzene, dissolves, or it's found that it dissolves readily in the solvent of 18 crown of 6. So here you can see this is 18 crown of 6. So on this kind of material you can see that potassium permanganate, which is not dissolving in benzene, can dissolve in this organic compound. So this type of crown compounds are being used as solvent for these complexes. So hopefully you have understood it, and we will have this chapter continued in our next session. Till then, goodbye.